Welcome to Dur-A-Flex, and more importantly, welcome to a new format for training contractors on the successful methods of applying Dur-A-Flex resinous floor and wall systems. Truly successful floor or wall projects rely on the actual products that are designed for a specific application. However, even the best products applied incorrectly will not make for a project that people are willing to pay for. You are now about to watch the steps that are required to take Dur-A-Flex products through a successful application. If you should have any questions, please do not hesitate to contact us at www.duraflex.com or by calling 1-800-253-3539 to discuss specific details with your local Dur-A-Flex representative. Please remember, at Dur-A-Flex we truly believe that your success is key to our success. The new Dur-A-Flex ESD epoxy answers the needs of customers that are concerned about the harmful effects of static on sensitive electronics and production equipment. To get started with this product, we will begin with a preparation of the concrete floor. After you have checked for moisture vapor transmission, the preferred method of abrading the concrete is to use a shot blasting machine. Be sure to grind the edges of the floor and the hard-to-reach areas with a 7-inch hand grinder. Before opening any containers of ESD epoxy material, be sure to check the MSDS sheets and the application instructions for a list of personal protective equipment and appropriate mixing equipment. Once your mix station is set up, we will begin with Duraglaze No. 4 ESD Primer. The primer is mixed at a ratio of 1 part hardener to 2 parts resin. Pre-measure your hardener first and then pour this material into your mixing container. Be sure to scrape out the excess material from the sides and the bottom of the bucket. Next, measure out the appropriate amount of resin and then add it to the hardener. Again, scrape the sides and the bottom of your measuring container. Combine the resin and the hardener using a slow-speed drill and a Jiffler mixer. Mix for approximately 3 minutes. Next, take the bucket of mixed material and pour a 4 to 6 inch ribbon of blended epoxy onto the floor. Spread the epoxy primer using an 1/8 inch notch squeegee. Remember, your goal is to apply this material at approximately 200 square feet per gallon. Next, wet out a good quality 3/8 inch nap roller in an area of excess epoxy primer. Using your wetted out roller, back roll the entire area to knock down the squeegee lines. Then cross roll the floor to ensure a nice smooth surface. Based on the area of the floor that you're covering, spiked shoes will make this step of the job much easier and safer. Allow the primer to cure for approximately 8 to 10 hours at 70 degrees Fahrenheit. Using 1/2 inch wide copper foil tape with conductive adhesive, your goal is to create ground points at a rate of 1 point per 1,000 square feet across the floor. Grounding points for the copper foil can include various spots such as steel support columns, drains, grounding pins, and some forms of electrical conduit. In order to ensure adequate resistivity across the entire floor, we recommend bridging, expansion, and control joints as illustrated. Now it's time to get started with the Dur A Gard ESD Top Coat. Pre-measure your hardener first and then pour this material into your mixing container. Be sure to scrape out the excess material from the sides and the bottom of the bucket. Next, measure out the appropriate amount of resin and then add it to the hardener. Again, scrape the sides and the bottom of your measuring container. Combine the resin and the hardener using a slow-speed drill and a Jiffler mixer. Mix for approximately 3 minutes. Next, take the bucket of mixed material and pour a 4 to 6 inch ribbon of blended epoxy onto the floor. Since the finished thickness of this product is critical, it is essential that you use a 3/16 inch notched squeegee to spread the top coat evenly. Pour each batch of the blended material directly onto the wet edge to ensure a consistent flow of the project. Following similar steps that were used during the primer stage, back roll and cross roll the top coat for a smooth finish. After the floor has cured for at least 24 hours, it is time to test the resistivity of the floor surface. Using a megometer, the floor is tested using 100 volts and should test between 10.6 and 10 to the 9th ohms. As you can see, our floor is well within the dissipative range and is perfectly suited to meet the needs of today's ESD sensitive environments.